All right, everybody. Let's see. Planning. Will that fit? Planning, working on dungeon game. Great. Okay. So let's see. For starters, what do I want? What do I want? File new. Okay. So I want to build dungeon game. Been wanting to do this for a while. Um, and I think I finally figured out how to actually make it. What happened? Okay, come on, drawing tablet. I think I finally figured out how to make it work. Basically, this is a top view. So you got your guy, right? And you got four directions you can move, and let's just call them W, S, A, and D, right? Now, if we take this and we rotate it, you can see that those arrow keys sort of follow it. Like I still go forward when I rotate. Um, so and I believe the way this works is that you can just represent that as so this is all related to the unit circle, right? So the unit circle, every distance from the center to any point on the circle is 1, so that's the unit. Um, and basically the formula here is x squared plus y squared equals 1. So, and there's a bunch of like complicated math you can figure out to like know an arbitrary point on, right? So like if let's say I have this point angle theta, um, you know, what's my x and y? But there's 4 points, um, 0, 1, 1, 0, negative 1, 0, and 0, negative 1, that happen to be trivial. Like, right? So x squared plus y squared equals 1, great. So if x is 0, then y has to be 1. Bam, you're golden. And just do that 4 times. And there's those are your four trivial results, right? And so it turns out that these are all 90 degrees away from each other. So there's these four directions. And so if I only ever move in 90-degree increments, then I only need these four. And I believe the way it works, um, arrange, gosh. Where are you? Okay, anyway, I believe the way it works is if I have just a list of these four trivial coordinates. So I don't actually know the order they're supposed to be in, but let's just say it's this. And I rotate my character, then I can just take this one, move it there, move these all over. And that's the same, and so I can just use that matrix to say, instead of say if I want to go forward n, if I want to go forward, I just say, well, forward relative to where my character is now. Like they're basically my character's forward. Um, then I just say, okay, take the first entry, the 0th entry in this matrix, and go for it. And so I have a blank project open here. We're gonna open another project. I think it was this one. And so the code I have here, no, not that one. remake maybe. I gotta name these things better. Yeah, I think it's this one. Okay, so okay, so in this case, I stored the right. Okay, so I have to do it completely differently here. So what this does is, what was the right? I can go this way. Okay, I can't turn, huh? Okay, we're just gonna get rid of this. I don't need it. So, oh, I forgot to mention, there's a bunch of other stuff. Where's my layer tool? Where did you put? New layer. There we go. But I can't access it because I don't have the. Okay. Arrange. View. No. What? What is it? Okay, it doesn't even. Okay. I don't know why Affinity's being like this. There should be a thing on my screen that lets me control layers, and I can't figure out how to enable it. Let me just Google that. No Studio Short. So yeah, I did that. Window, Studio. Window, Studio. Why is it grayed out? Grayed out. Why is it grayed out? This is dumb. Maybe I should just start working with GIMP. Alright, GIMP, don't let me down. And for GIMP. Oof. There. What's all these settings? Okay. Yeah, okay, so I can just. What was I even talking about? Okay, we're just gonna ditch Affinity for now. Okay, why is pressure not happening? Dynamics. Oh, for pencil, I want brush. Brush should have. Nope. Size. Okay, I guess we're stuck with fixed width until I can get this working. Or wait, is it? Does you need? Nope. Why is? Okay. Maybe all art programs are just bad. Let's just close Affinity. Okay. So, well, okay. Okay, so select view, window, studio, presets, normal, apply. Okay. Um, view, show tools. Okay, that gets rid of my tools. View, show toolbar. Okay, view, LUI. Nope. View, window. Okay, so hide studio, show right studio. Okay, finally, we got there. And now I can look at my layers. Nice. Okay, gosh. You know what? One sec. I'm gonna go get some coffee because I'm not thinking. I need to be thinking. That's how programming works. You turn thoughts into code. Okay. Uh, where? All right, let's see. Turn my camera back on. And for your viewing pleasure, let me tilt this up a little bit. Where's my mic? It's got to be a audio visual experience here. There we go. Okay. So we are back. I didn't actually coffee, an energy drink, same diff. And let's start over. Because I think no one probably watched the first 10 minutes of the stream anyway. I'll just leave a comment below telling everyone to skip ahead a little bit. Okay, so what is Paper Dungeons? I gotta organize my thoughts here. Okay, let's start with what it feels like to play. So gameplay. There's basically 3 types of places. There's the town. There's the overworld. And there's the dungeon. Now, the dungeon, you're going to spend like 80% of your time here probably. Rough guess. No promises. Yeah, I don't know how you play the game. But 80% of your dungeons, we're going to focus on 80% of your time in the dungeon, so let's focus on that. So, what's the dungeon like? Okay, so this is based on Ultima. And Ultima had a grid-based system that was 8 by 8. I think each tile was like 5 feet or whatever. Just to make it simpler, because my game engine is in meters, this is going to be 64 meters. So a tile is basically your Minecraft state, right? So it's 1 meter long and 2 meters tall. And you got 64 of those. And then each room, this is not what the dungeon's eventually going to look like, but just so it's easier to see. Right? Each room is going to be color-coded to make navigation easier. This was a major frustration when I was playing the original Ultima. It was just very easy to get lost. And unlike Ultima, these are all going to be handmade. Hence the name Paper Dungeons. Why is it called Paper Dungeons? Great question. Because I want to build it out of paper. So what do I mean by that? I want to build it out of paper, so it'll be probably like 2-inch scale, so 2 inches equals 1 meter. And then I'm going to put a little camera here, and I'm going to take pictures. Now, the game only respects 4 angles, which are 0, 90, 180, and 270. So 0 equals 360 in this case. And so my camera, this is a top view, is only going to take pictures from those angles. And then we're going to have all the other stuff, so ladders to go up and down, bats or whatever this creature is, right? Also going to be made out of paper. And I'm just going to overlay those in the engine. But I want it to be a very sort of like basically a video game board game, right? So I want to follow board game rules to the extent that you could make, like, in order to make this video game, I have to make a board game that's identical, if that makes sense. And the inspiration for this is actually, I played Sunset Overdrive. What was it? Not Sunset. Burnout Paradise. And Burnout Paradise was like, this is really fun. I wish I could take little RC cars and like make a game world with like random crap I had lying around, and like, and it turned out to not work just because Burnout Paradise. Burnout Burnout Paradise map is massive. So 38 miles square, right? So 38 miles square, even, and then the smallest. So the easiest RC car to get your hands on is the RC, which is 1/64th scale. So 38. So actually, what's the square root of 38? Okay, over 64. Okay, times 5280. So that's 500 feet by 500 feet. So let's go to Google Maps. Let's go to Paris. Oh my God. Um, does Apple Maps support measurement? No, but we can rotate to make it easy to. So 500 feet is So what's a good point of reference? Oh, okay. So this river, whatever it's called, is like 500 feet wide. So you can see why this isn't tenable. And obviously I can make an even smaller map, but you know that map would have to be fucking huge if you wanted to actually build it. And obviously, and right, you can get smaller cars. I think I saw a tutorial for making it 150, but that's still 250 square feet. Or it's still, or no, it's still 250 like feet. Anyway, this 1 inch equals 2 meters. What or two, either 1 inch or 2 inch, depending on this. All depends on the size of the camera. So I've been looking at like small cameras that can take good pictures. Um, and so if I can get a camera that is, that sort of perfect 2 inch by 1 inch size, or smaller than it, I can bulk it out, or like a little bit larger and I can fake it. Then I only need 64 inches for those metric friends among us. 64 inches to centimeters is 100. Okay, so that's actually pretty straightforward. So I'm pretty tall. I am about 6'3", which translates to about 185 cm. So if you are, about 20 inches shorter than, or 20 centimeters shorter than me, so this is a short child, a short adult, or a tall child. That dimension on one side twice. So, yeah. So it's very reasonable. Now the issue, of course, is that I need to do several of these. I want to have a deep dungeon, maybe 8 floors, and we run into issues there because we do some quick math. So I'm gonna have a camera pointing in a direction. I'm gonna rotate it 3 times per tile, or I can have 4 different pictures per tile. So 64 tiles times 4 pictures per tile times 8 floors is, I actually don't know what that is. I'll find out, but it's a lot. Okay, 64. Okay. 6. Come on. 64 times 8 times 4. Yeah, so we're around 2,000 pictures. Which is a lot. Experts would call that a lot. And that's not counting all, like, I want to have enemies. And because I'm using pictures for everything, all the only way I can really make them look further away is to just take pictures at like 1 inch, 2 inch, 3 inch, etc. Just sort of same thing with treasure chests and ladders and all that. So let's just add 500 to that for all the props. Now 2,500 pictures. I don't actually know how long that'll take. It could be really fast. It could be really slow. I don't know. So because this is a lot of pictures, and I only want to have to do that once, what we're actually going to do in order to make the game is we're going to prototype it in 3D. Right. So it's going to be basically it's going to be a lot of pictures, a lot of pictures, and then we're basically going to have so let's say you're on floor 1. You're on the first position, so you're in floor 1. You're at the 0, 0 coordinate, and you're looking north. Right, so that's one picture, and then if you look east, that's another picture, and so it's basically stored as this massive table of pictures. And so I'd basically just have the file names arranged something like this, and so I just say instead of rotating the character at all, instead of rotating them, I don't actually need to do anything. I basically just need to have some way to hold the data, like the screen, to display it, right? And so we have the dungeon you're in, all that detail, and maybe a HUD, so you got 3 health left or whatever. And then maybe there's an enemy, but that's all I need to render. There's no actual 3D because it's all 2D pictures sort of stacked. But because let's say I make a mistake, right? So let's say that I have a dungeon layout. Let's say I have a dungeon layout like this, and I hate this, and I actually want to make a dungeon layout that's something different. Well, great. I have to take all of those pictures again. And I'm also assuming that this is very, very optimistic. So, for example, there's probably going to be some problem that's going to make me retake a bunch of pictures. So, if I bump the camera or the lighting's wrong or any number of other things. But anyway, that's the basic idea for paper dungeons. So there's also going to be an overworld. So basically, here's the town, here's the dungeon. How do you need to get through here? And there's monsters and stuff. That's the basic design. Doesn't have to be too complicated. And this is going to be in 2D. So I'm basically going to just draw on a piece of paper. The overworld, you're going to draw that once. You're going to draw all the monsters, but they don't even need to be drawn more than once. They just move around. Quick and easy. And then it's going to be the same logic. So Ultima, for some reason, has, dungeon, town, and overworld. 3 different combat systems. So the rogue, the damage calculations are different for all 3. It's weird. I'm not going to do that. I'm just going to have myself in the same place. And then the town is going to be very simple. Basically, it's going to be one screen, and you go in, you buy whatever you need, you leave. It's not going to be too complicated. Because one thing I really like about the original Ultima is that immediacy. Trekking over the overworld is relatively slow because you got to fight monsters, and the distances are fairly large. But in the dungeon, you press a button, you go forward immediately. There's no waiting. You press attack, you attack immediately. There's no waiting. There aren't even attack animations because they couldn't afford it. There just wasn't the processing power at that time. And so I really like the snappiness. I want to keep that. So the first thing I need to do now, again, I'm not actually going to try the final game. I'm going to do everything in my power to not actually render anything in 3D. It's all going to be 2D. It's all, well, it's going to be, the pictures are made out of 3D objects, but it's all going to be pictures. But I do need to prototype. And I need to prototype in 3D because the dungeon is going to be in 3D. So we're going to start with that. And we're just gonna, for now, I'm just gonna add a CSG box 3D. Just to test my. Okay, let's change the transform to 0. There we go. Okay, so this is just to test my movement code. Give it a texture of some sort. I'm just gonna use the thumbnail. Let's just use this thumbnail. Sure, whatever. That looks terrible. But when we're moving, we should be able to tell that we're moving and rotating stuff. Now let's add a child node, just gonna be a camera. Now usually we'd have a player. Transform should be 2 meters up. There we go. Usually we'd have a player, but we don't actually need one because we're gonna handle all our collisions ourselves. We're not gonna worry about collision right now. We're just gonna add script here. Add child, oh wait, not child node, add script. Okay, so we don't need a ready right now. Okay, so process. If input is action just pressed forward, and then I need project settings, input map, forward, back, left, right, rotate, left, and rotate right. Oh, and also exit. So forward, back, left, right, rotate left, rotate right, and of course exit. Great, so dot. There we go. Okay, so now if we run this code, oh, cancel. Let's call this main. Okay, well I goofed it, but position dot z because it's y up. Minus equals 1. Okay, great. Right, so great. Now we just need to copy paste that 3 times. And if there's a better way to do this, please let me know, but I'm just gonna, come on. Right, so position back. And we're gonna change all this later. Position left. We want to go on the Y and on the X. And I'm just gonna brute force sort of just guess and check until it works, because there's not that many possible ways it can break. Okay, so forward, back, left, right, bam. Cool. Now I need to add rotation. If input dot is action just pressed, rotate left, left, left. Rotation degrees plus equals 90. Point 0. Oh, wait, 0. Okay, so rotation degrees dot y. And we're just going to do the same thing the other way. Right, minus plus 90. Why is this not working? Oh, okay, rotate right. So he's doing both of those at the same time, and that was canceling itself out. So, okay. Right. Let's see. Let's change the CSG box to be nope. Wait, 180 makes it. Nope. I want 180 on the. Oh, okay. Try 180 here. Nope. Okay, so if I actually check. Okay, it's facing. Wait, it's facing sideways to start. Okay, so. Oh, right, and we need to restart this because I haven't actually implemented rotation working. So, left. Wait, I'm just. Okay, if I go that way. Okay, that is left. That is right. Okay, I believe that's correct. Okay, great. So we've got our basic movement code working, but it breaks itself. So rather than do all of this, we're gonna have let me look at a unit circle. Okay, so 1001. Right, so var um uh What's going on here? Okay, this is annoying. Godot is being too smart for its own good. There we go. And then, so this is a two-dimensional array. So 1, 0, 0, 1, 0, 1, minus 1, 0, 0, minus 1. Or maybe it should be, maybe they should be parentheses. That looks neater. It's still giving me an error though. 4.2.1. Okay. Wait, that's 5 years ago. Oh my god. Duplicate, slice, 2D array. Okay, so 2D array. So great. So let's see. Control C, Control V. Okay, let's try rotation directions. Okay, so actually, I'll be right back. Where were we? 2D array. Okay, so equals. And we need the okay, so 1 1 0 1 0 0 1 minus wait, it's minus 1 0 and 0 minus 1, right? Oh, I see. You need a comma here. Great. So okay, just realized I don't know how to integrate these two. Okay, so wait. So this would be okay, so we've got these four possible directions. But four possible directions and four possible rotations. Okay, so how does this all work? Right, so our current thing is minus 1 0 1 0 0 minus 1. Oh wait, no, reverse that. 0 comma minus 1 0 comma 1 minus 1 comma 0 and 1 comma 0. Okay, and so these are not in unit circle order, of course, because we're doing. Wait, no, it's yeah, because we're doing, you know, sort of the y and then the x, and we're grouping them. Where they're in the unit circle, it's x equals 1, y equals 1, x equals minus 1, y equals minus 1, right? But what we can do is wait. Okay, so if I'm here. Okay, so first of all, let's just reorganize this code so that it matches the unit circle. So position dot. Wait, actually, how do I? Okay, so we're ignoring the z-axis for movement. So if I have position dot z minus equals 1, okay, so that's the same as this fourth array, right? So minus equals rotation directions of 3. Does that have the same effect? Okay. No, it does not. Oh, okay, so we just got plus equals. It's always plus equals. Rotation degrees of, right, because subtracting negative is the same as adding positive. 2, or 1, 1. Forward, back, great. And then this should be, this is the minus, so -1 should be 2. Yeah, 0, 1, 2, 2, 0, and 0, 0. Okay. Now that was my idea for, and then my idea was to like rotate it. Um, let's try rotating it. Rotation directions equals. So let's just take this. C. Okay, Control C. Control V. Take this first element. Move that over here. And what does this do? Okay, no, I need to use both. Position. So I need to use both. Position.z, position.x. And then let's just put that in order so it's easier to read. One, 0, and that's x. G1, and that's z. And that's z as well. So now, if I move my character, okay, it's all goofed, but wait, so that, what rotation is that on the unit circle? We're basically rotating our unit circle. So if we start with 01, we're starting from here. So we've rotated 90 degrees. So that's plus 90. So Control X. Control V. So now if we run this, forward, back, left, right, great. Now rotate 90 degrees. Oh, plus 90. So now if we, okay, forward, back, left, right, all work, rotate 90 degrees, Forward, back, left, right. Okay, it's backwards. Let's see if I make this minus 90. Forward, back, left, right. Works. Forward, back, left, right. Great. Okay, because it's going backwards that way. Okay, so that actually works. Now I just need to figure out how to rotate. Duplicate, index, shuffle, reverse, remove. Can I just say declare, resize, fill, modify? Okay, so remove at 1. Okay, so if I just say rotation directions of remove an element, add, insert. Okay, so okay, rotation directions dot insert four comma rotation directions of 0. Great. Rotation directions dot remove at 0. Okay, let's just get rid of that for now. Okay, so that should forward, back, left, right. Great. Forward, back, left, right. Okay, now we just take this, copy paste this here, and just swap these values. 0, 3, insert 0 from yeah, insert 0 from 3, remove. Okay, let's just see how that works. Nope, does not. So okay, so in this case we're adding an element at array 4 and then popping off array 0, so it's still 4 at the end. Let's just print rotation directions. So if we just Right, so yeah, so if we make a full, wait, yeah, so we make a full circle here. Great. So now I just need to, do that backwards. So rotate, so in this case, I'm taking the 0th element and putting it at the 4th element. But there's no 4. Okay, so I think I still need to, if I, wait, what if I just add, yeah, just, well, if I insert it, rotation directions dot insert 0, 3, print that. Run that. And then let's just pop off the rotation directions dot remove at 4. How about that? Will that do a rotation correctly? Oh no, the frame of reference. Okay. Camera 3D, reset your position. Okay, great. So, wait, what? Oh, it needs to be, yep. There we go. Forward, back, left, right, great. Forward, back, left, right. Forward, back, left, right. Forward, back, left. Okay, forward, back, left, right. Forward, back, left, right. Forward, back, left, right. Okay, so, boom. We use trigonometry. Yay. Oh, and then it only took us an hour. That was reasonably efficient. I just realized this code is probably going to be a pain in the ass to maintain. But it does work. So now what? Now I need to figure out how to use dungeon tiles. Or what was it, like 3D tile sets? Tile map. Oh, and I've got to, oh, I'm just gonna check this off. Okay, great. Okay, tile maps, but 3D, great. So what the hell is this guy's deal? Let's check this out. Block element. Yep. Great.
I am ashamed about my past comments regarding grid maps. Being honest, I hate it. I hate it. I hate it. This is why today we are facing the task of using grid maps the good way. Probably you will be facing the same issues as me. When using the 3D tile map known as grid map, those issues are misalignments, displacements, weird rotations, and we will tackle all that stuff now. This story, I started taking a look into the Kenny webpage. I saw this asset pack. Oh, it's lovely and remembers me the PS1. And a weird feeling sizzled my spine. So I downloaded, extracted, and imported into Godot. Just because I was in a focused way.
Okay, so we're not going to do that. We're going to make our own. That shouldn't affect anything. Whatever. We'll just watch this video and then open up Blender, I guess.
In the past. We will cover it later on. First, the well-known process is easy. Load all the assets in the scene and then click on the Scene Export as Meshlib. Then create a grid map and select the meshlib you want to use. Placing it's really easy. Selecting the tiles and placing into the cells. Remember, ASD keys rotates the pieces, and we are using mainly the S key to rotate along the Y-axis, and the W key resets all the selected rotations. To speed up things, you can select an area when pressing the Shift key and dragging your mouse. And with a selected area, you can copy and paste in another place to fill, or just fill the area with the selected mesh pressing Ctrl F. And depending on how optimized the tiles are, you will face issues like this one, misalignments or displacements. And said previously.
Okay, so let's see. That's 3.2. Okay, let's see.
You know that I want to cut this into, I want to divide this by 4, and I'm going to click.
Okay, here we go. Create wall tile.
Okay, I've got Blender open now, and we're just going to hop right into making the first of 4 tiles. So, brand new Blender project here. I'll press A to select everything, X, and then delete everything. Shift A, mesh. I'll add a new plane mesh. This is currently 2 by 2 meters, but we're going to make the tiles 1 by 1. So I'll press S and then 0.5, enter to scale that down to 1 meter. And go tab into edit mode. And then press 2 for it to select. Let's grab this back edge and start building the wall up here. So EZ1, enter, EZ1, enter, EZ.5, enter. We're going to be beveling the ceiling a little bit. So let's move this in a little as well. So GY, negative 0.5, and then we'll just finish off with a flat ceiling, EY, negative 0.5. Okay, perfect. So now I'm going to go into the UV editing menu over here, and we're going to apply our texture atlas to this. So first, let's hold middle mouse.
Okay, so... Okay, I don't care about all of this. Here you go.
Okay, we've got all of our tiles made, so just a couple more things, and then we're going to export this into Godot. So back in the layout tab, make sure you're in object mode. I'll click this extra wall tile here and delete that. Let's just move these around so that they're positioned nicely for a tile set. I'll click this one, GX control drag, and I'll just control drag all of these ones out a little bit. Then this one, G, Shift Z, and control drag it right there. Okay, and then A, control A, let's apply the rotation and scale so that these are all scaled properly on import. In the beginning when we made this first one, we actually did scale the plane down by a half. So if we didn't do that, these actually would be scaled in a funny way when we import them. So make sure you do that. And then the last thing we're going to do is we're going to name all of these objects so that they have collisions on import automatically. So for this one, for example, I'm going to call this one wall-col. So you can name them whatever you want, but the -col just makes it so that it automatically has collision when we import it. So let's just do all of these. This one I'll call corner-out-col. This one corner-in-col. And this last one I'll just call floor-col.
Okay, now how do I...
Press A to select all of them. File, export, gltf2, tileset.glb, include selected objects, and all of these default import options should be fine, but I'll go through them here just so that you can see what they are. Okay.
Oh, got a little cat. Where's my cat? I can't even see you. Are you under my desk? Hello, cat. Hello, cat.
Then we can export it, and we can hop over to Godot.
You want something, don't you, cat? Alright, I'll be right back. Kitty cat wants something. All right, well, she's got food and water, so other than that, I can't really provide those for her during a stream. So we're just gonna keep going.
Okay, I've got a brand new Godot 4 project open here. All I've done is just made this super simple first-person controller using the character body 3D template script, and that's it. So I'm going to go ahead and hide this plane, and then right here I've got the folder where I exported that tileset.glb, so I'll drag that into the directory here. Then I'll right-click it, new inherited scene. Everything's looking good. We can see the collisions are there because we gave it that export hint. So I'll save this as tileset.tscn, then I'll go to scene, export as mesh library. I'll just still...
Oh, literally use. Okay. Okay, what time is it? Okay, we've been streaming for a little over an hour. Okay, so Blender time. All right. Hopefully my mic isn't picking up too much of that. My roommate is laughing / coughing in the other room. Okay, so don't. All right. I don't. Okay, don't need the camera. Okay, that's. Keep getting interrupted here. Um.
tile set, merge with existing's fine, exported that tileset.glb, so I'll drag that into the directory here. Then I'll right click it, new inherited scene, everything's looking good. We can see the collisions are there because we gave it that export hint. So I'll save this as tileset.tscn, then I'll go to scene, export as mesh library. I'll just still call it tileset. Merge with existing's fine. Apply mesh instance transforms. You don't want that selected. I'll click save. Then let's go to the world. Let's add a grid map node. To our world, go to cell, change these to 1 by 1 by 1, and then uncheck center Y. I'll drag in node to our world, go to cell, change these to 1 by 1 by 1, and then uncheck center Y. I'll drag in the mesh library resource right here, and then let's paint some floor
How long has my mic been unplugged? I need to glue that in or something. Anyway. Do I want to wrap up stream already? I think I do, yeah. So yeah, for next time, so that was basically what we got done today. For next stream, and I don't know when next stream is. I don't want to wait until usually when I do stream. I might want to do like more streams closer together for at least for game development. So today we've got very basic movement. Okay, so for next time, Ray casts wall tiles. Collision. Raycast wall tiles and collision, so I can bump into wall and not go any further. Jump animation. Wow, this is for movement and ladders, I guess, because I need to scene. Right, so I want to have 2 floors and I can ladder between them, and so these are both scenes. Right. Scenes, so I need to be able to swap between those. File, save as. Dungeons to do. Right. Okay, cool. I think I'm gonna end it here. Thanks everyone who came. I don't think there were a ton of them, but thanks everyone who came. And yeah. I will do another stream soon, maybe even today, who knows. It's Thursday. Okay, so yeah, I have a longer shift tomorrow. So probably not then, but maybe wait, today's Thursday. I have a longer shift then, but yeah, maybe later.